Okay, again we call for the question number 2 from the CIE paper about the stress, strain, and the Young modulus. Define the strain. What is the meaning of strain? Strain is the extension divided by original length or per original length. Because we know that strain is extension delta x, let's say, divided by x. A copper wire of length 4 meter has uniform cross-sectional area of 4.5 times 10 to the power of minus 7. And then this, calculate the Young modulus. Young modulus is stress divided by the strain. The stress is force divided by the strains is L per delta L. So the formula for this is F times L per A times delta L. Okay, I make it becomes times because it is divided by delta L per L. So L is going up and then divided by delta L. Okay, so the Young modulus is equal to force. Force is 18 divided by area. Area is 4.5 times 10 to the power of minus 7, and then okay, 18 divided by area is 4.5 times 10 to the power of minus 7, and then times again delta L the length, the original length, which is 4 meter divided by delta L, which is 1.4 times 10 to the power of minus 3. Remember, we have to convert to meter, yeah, all of the length. Okay, using the calculator, we have this times this is 72 divided by 4.5 times 10 to the power of minus 7 times 1.4 3 minus 3. I got 6.3 times 10 to the power of minus 10, and we divide them. 72 divided by 6.3 minus 10, which is 1.14 times 10 to the power 11 Pascal. Yeah, this is the answer. And then for II, on figure 4.1, draw a line to show how the stress varies with the strain for the wire up to its limit of proportionality. Stress and strain. The first we have to find the stress. The stress is equal to, okay, the stress, which is this, is force divided by the area. Remember, the force is 18 and area is 4.5 minus 7. So 18 force over area, which is 18 divided by 4.5 minus 7. So the stress, using the calculator, we will get 18 divided by 4.5 minus 7, which is this one, 4 times 10 to the power of 7. Yeah, 7 Newton per meter square. And then for strain, we have delta L divided by L. We remember that delta L is equal to 1.4 millimeter, and L is 4 meter. So 1.4 times 10 to the power of minus 3 divided by 4. This is 1 is meter. That's why the extension does not, the strain does not have a unit. So E is equal to 1.4 to the power of minus 3 divided by 4, which is equal to 3.5 times 10 to the power of minus 4 without the unit. Okay, so for the stress is 4 times 10 to the power 7, which is here, yeah, at here. And then for extension, for the strain, 3.5. This is minus 4. Okay, so 3.5 in the middle, this one. So we are going to make a line from 3.5 to 4, such like this. Okay, if we extend the graph, so the graph will be like this from this point, from the original to that point, like this. Yeah, one bit like this. Yeah. Okay, anymore? A second copper wire has the same length as the wire in B but a larger diameter. Both wires are subjected to tensile force of 18. By placing a thickening through, complete table 4.1 to compare the stress and strain of the wire. Okay, greater second wire stress and strain. We have to compare. The copper wire 1, the copper wire 2, yeah, is okay. The diameter of the copper wire 2 is larger. Larger means like this, yeah. Larger to the diameter of copper wire 1. That means that the stress, which is this 2, the stress is equal to force divided by area. Okay, so if the area is up, increase, okay, meaning that the stress will be decreased because this is inversely proportional. So this must be less. Okay, so the stress is less. The strain is epsilon, which is delta L divided by L. We know that the diameter is larger. It means that the delta L will also smaller. Yeah, it is because larger diameter. Okay, so the answer is last 2. Okay, I think that's all. Thank you.